This is page 34 on your notebook paper. Please put 34 in the top right corner, and then look at just the cover for a second. Let's talk for just a second about the word quadrilaterals. Go back to what you know about triangles. What is an equilateral triangle?
Equal sides.
A triangle where all three sides are equal. A quadrilateral has the word lateral, which is the prefix or the suffix for the word side. What do you think quad stands for? Four. Not necessarily equal, but it does stand for four-sided figure. Okay? The actual definition or the actual vocab word is called a polygon. You'll probably recall from middle school learning about a couple of basic polygon shapes. Polygon means straight segments that have been put together to create objects. There's no curves. There's no open-ended. It is a closed shape. The smallest polygon you can make is a triangle. You can't make a polygon with two sides because then it would either curve or be open-ended, and that's not possible. Smallest polygon possible is a triangle. We are now studying. I'll get it. I promise. We're now studying four-sided shapes, which are called quadrilaterals. Although your flip book includes the word trapezoids, we will not actually be covering that. We will just glance at it when we are done so you can see what the general shape is. But as far as needing to know the properties of a trapezoid, you do not. I have good news and bad news. Bad news is there's a lot of stuff to cover. Hence the flip book. Good news is I'm not asking you to memorize any of this because I realize there is a lot here. Some of them are very similar and it's easy to mix them up. I'm not asking you to memorize it. In fact, when we take this test, which will be over just this stuff, I'm going to give you, it's like a study sheet, or if you want to call it a cheat sheet, you can. But it's a study sheet that lists all the properties of each shape so that you don't have to memorize it. You just have to know when to use it. Okay? So today we're going to start with parallelograms. If you will take the top cover and gently fold it up and crease it so we can write on the inside. You will notice the top flap is where we're going to list the properties. The bottom flap is where we're going to practice a few examples. I'm out and I'm thirsty.
He doesn't.
No, he doesn't. Somebody? Oh, yeah, sure. Just really thirsty. All right. So look at the top of this. It says properties of parallelograms. You will notice there is a blank picture to the left of it. Then all the properties listed, we're going to fill in the blanks. Then we have an example here with what's called diagonals drawn. Then we have an example here with no diagonals at all. The first property of a parallelogram, what word do you hear in the name parallelogram?
Parallel.
Thank you. Opposite sides are parallel. That's the first property. Opposite sides are parallel. The second property, what does it look like in terms of length? Opposite sides are they're equal. We're going to write the word congruent.
I should put the sign.
If you want to. Okay, we need to make some marks on our picture to indicate that the sides that are parallel and the sides that are congruent. If you go back to the lesson from 2 or 3 weeks ago, parallel lines cut by transversal, remember that? That's going to come in, by the way. If you recall the parallel lines cut by transversal, when we had parallel lines, we had one of two little notations on the picture. It was either two little triangles or it was two little arrows. Not necessarily two, but it was arrows to show that, hey, those are parallel. And then now if I want to go to these, I need to do a different number of arrows to indicate that I'm going in a different direction. So those little arrows are your indication those are parallel. So if you need to, if you don't remember that, take your pencil, draw an arrow like to it, and make the note that means parallel if you need to. Congruent marks was just the little tick marks. You already know this. I'm going to change colors so it doesn't blend into the arrows. Congruent marks are where you just make a mark to say, hey, that's equal to that, and then you need to make a different set of marks to show a different set are equal. Got it? Hold on, I'll just... Opposite, I'm ignoring, I just let that, I'm ignoring that. Opposite angles are blank. That would be congruent. If you will, direct your attention to this problem right here. Let me circle it in case somebody's watching the video. You don't have to circle yours. Don't circle. Just watch. If you'll look at this one right here, this one's easier for me to talk to you about than the first one. So much. This one's easier to talk about, and that's because if I tell you, look over here at this one. If I tell you to direct your attention to angle A, everybody divert your eyes to angle A. All right. Here's the problem. You can be looking here, you can be looking here, or you can be looking here. There's three angle A's. When the diagonals are drawn, it's harder to talk about the corner angles because now there's actually three with that one letter. So that's why I want you to direct your attention to this one, because if I say put your eyes on angle Q, every single one of you should be looking right there. Correct? Okay. The property we just stated was that opposite angles are congruent. They're equal. Angle Q would be congruent to angle S. Angle P would be congruent to angle R. So when we say opposite, we're talking about the angles on the opposite ends of a diagonal. But with the diagonal not drawn, it's easier to talk about, right? Okay, so they're congruent, all right? Now let's look at this. Consecutive angles, that should sound familiar. Don't write this. Think back, parallel lines, cut by a transversal. Consecutive angles were on the same side of the transversal but inside the parallel lines. Remember those? They were the only ones that add to 180. Remember that? And it was because one of them's always acute and one's obtuse. So they're not equal to each other. They add to 180. Same thing here. So consecutive angles are supplementary. If you need to put a refresher right there, put 180. Then the last property that's listed says diagonals blank each other. The word that goes here is bisect. Do you remember what bisect means? Cuts it in half. Bi means two. Intersect, it's intersecting to create two equal parts. We are going to make marks on our picture. Be careful. Don't make them too big because then it's going to get really crowded. So we have the diagonals drawn. It says they're cut in half. That would mean that this is equal to this, right? And then this one over here, this is going to be really crowded. 1, 2, 3, 4 is equal to 1, 2, 3, 4. Now, you should have, don't quite have it, so write it up here. I'm looking at what kind of margin. You have a little margin right there. You should have a little bit of a gap in the fold. And if not, then just come up above it. I'm going to have to write it up here. If you don't have a gap wide enough in the fold, then come up to the top and write it up across the top. Should have refilled that a long time ago. Here's what I want you to write in that margin or wherever there's space. There's an additional property that I want you to put on your paper because it's going to come up. May not come up necessarily in this one. Actually, it looks like it will in example 1. And it's going to help when we start doing the practice problems. Just copy it down. I want you to write, look for alt, int, angles. What's that stand for? Look for alternate interior angles when diagonals drawn. I know it's a lot. Look for alternate. Okay, see, I told you. That's it, go.
Spider bite.
Changing to. Is there a Miss Spider? Spider-Woman? There is one. Black Widow?
It's a spider.
But there's also
It's
spider
not
when she's
a
white.
spider.
Gwen Stacy.
Yeah.
Gwen Stacy.
There's a lot more spider.
I said Harper
There's literally a show called Spider Woman.
All right.
Yeah.
Let's look at example 2. We're going to look at example 2 because it's easier than example 1. Example 2 is an algebra problem, and I know I said no algebra till tomorrow, but this is something we already talked about, and you should be familiar with this. So look at example 2. It does tell you, hey, you have a parallelogram, right? Then it says find the measure of angle PSR. Well, here's one of those where I feel like the angle could be named by a single letter, and it would be a lot easier. I want you right now to trace with your eyes angle PSR with your eyes. I want to make sure we're all looking at the right angle. You're tracing your eyes over angle PSR. And then now I want you to put your eyes on the single letter that could be used to name that exact same angle.
Yes.
Yeah.
Yeah.
Did you direct your eyes right here?
Yep.
Okay. So where it says find angle PSR, it really means find the measure of angle S. Okay. So now you have to look at what you have in front of you, and you ask yourself, what did they give me? Did they give me sides, diagonals, angles? They gave me angles. Then you look and see, how are the angles positioned? Are they opposite or side by side? If you were to trace side QP, would you be touching both of those angles?
Yeah.
So then they're side by side. That's that consecutive interior. And what did we say they are? They're supplementary. If you don't understand the connection, let me show it to you. What did we say exists in every parallelogram? What was the first property? Parallel lines, right? So you have parallel lines here and here, clearly not those, with a transversal And then bam, there's your consecutive interior angles from that lesson 3 weeks ago. See it? So that's why this exists. So the relationship is that angle Q plus angle P has to equal 180. So now you're going to plug it in and solve. So you do that now. Yeah.
You
Yep.
give me calculator, Luke? No. What?
Yep.
There's none left. Take my phone.
I'm charging. Everybody was telling me the batteries were getting low, so I was trying to charge them.
Well, now I gotta use my phone.
She didn't.
You have calculator 84.
Here, there's that one. That was short. Alright. Solve it for X. Should be pretty.
Uh-oh. I need to calculate. Not just
Solve for X. Now remember, it didn't say find X though. It said find angle S. What did you get for X?
Did you set them all?
Who do you do, Jackson? You did this. What? No. No, you can go down and I'll figure it out.
You're fine. I was giving everybody time to solve for X.
You be quiet. No, you're not.
Did you get 18?
Nope.
Yes. That should be 180. 198. Did you get it? When you add 18 to 180, you should get 198. That should be 18.
I subtract 18.
Right here, negative 13 minus 5 would be negative 18. Right?
Okay.
Then you're going to add the 18 over.
Get it? When I put 180 plus 18, my
alright.
brain thought it
Now, it didn't say find X, it said find the measure of angle S. We don't have an expression for angle S.
Plug in Q because Q
Why?
and S are equal.
There you go. Opposite angles are congruent. So Q and S are opposite. So to find the measure of angle S, I can use 7x minus 13 and plug 8 into that. And then tell me what you get.
113.
Everybody plug it in. Remember, don't just wait for the answer to go on the board, because then when we take the test, you're going to be in bad shape. Now direct your attention to example 1. No algebra, but there is a lot going on here. This is why I don't like example 1.
I don't like it either.
we're just gonna go through it one thing at a time. We do have diagonals drawn. That does make naming the angles require 3 letters. So be very careful when you're tracing the angles to make sure you're looking at the correct angle. So look at this. Notice A, B, and C are only 2 letters. Notice D, E, and F have the angle symbol. That's letting you know that these are lengths and these are angles. Okay? So if you need to make a note to yourself, okay, this is what it looks like if it's talking about a side or a diagonal length. And then this is what it looks like if it's talking about an angle measure. Big difference, right? Okay, we have a lot going on here. Let's look at what we know. Notice that if it has a degree symbol, it's referring to an angle. If it has this little M, it's referring to like a linear measurement. Okay? We do have diagonals drawn. We do know that it's a parallelogram. Okay? It says find side AB. AB is here. Your first indicator would be, do you know the side opposite of it? And what's it? 8.4. What do you know about opposite sides? They're congruent. So AB would be 8.4. Then it says find AC. Okay, it's not a side, it's a, starts with a D. It's a diagonal. Go to your properties. This is how you use this properties list. Diagonals bisect each other, meaning cut it in half. Do you know any portion of the diagonal?
Yes.
You know part of it's 10. So what's the other part?
10.
So what's the whole thing? See how to use this now?
Yes.
You're going to have that in front of you on the test. You just have to know how to use it. BE. Wait a minute. Why can I not find? Oh, there it is. BE. Okay, I'm really glad you said 33. Very common. Very common. So glad you said it. I'm using it as a teachable moment. Very common mistake to just take a number next to what you're finding and think they go together. BE is a length, and 33 has a degree symbol, so those are apples and oranges, so be careful. BE is a diagonal. Ask yourself, do you know the other part of the diagonal? The other part is 7, so this would be 7. Y'all see that? Let her know. Now we're going to look at angles. Now here's where you have to be careful. I'd much rather work with sides and diagonals because it's just 2 letters. Angles, when diagonals are drawn, are 3 letters. Trace it and go back to the middle letter. So it says find angle BAD, so BAD, and it would be this entire stretch, right? From here to here. Now you have to look for clues. Yeah. So your clue is that this little piece here is 23. Right? Well, it's... What'd you say? No. So, if you look right here, there's a lot of ways to go here, and I'm trying to think of which way y'all probably see easiest. All right, direct your attention to the angle opposite of it, the entire angle opposite. So over here, right?
Yes.
We know that opposite angles are congruent. Well, if you look over here, do you happen to know that entire angle? No. You know a chunk of it, though, is 43. So now something's weird. You should think to yourself, now wait a minute, that one was 23, that one's 43. Those aren't the whole thing, that's just a piece. Enter, look for for
Alternate,
alternate interior angles when the diagonal has been drawn. Let me remind you what alternate interior angles are.
Doing five.
If you have parallel lines, oh, that was too close. If you have parallel lines cut by a transversal, alternate interior angles were on the opposite sides of the transversal but within the parallel lines, and they're congruent. So if you look at this picture right here, this diagonal is the transversal between these two parallel lines. You with me?
Mhm.
So if this is 23 here, then this is what? 23 as well. And if this is 43 here,
From that.
then this would have to be 43 as well. So 66. Does that make sense? That's a tough one to start out with in terms of the angles. Alternate interior angles are embedded within the parallelograms, and it's only if the diagonals are drawn. If the diagonals are not drawn, then you just have the opposite angles or the consecutive angles. All right, so that was a lot to write down. Let me erase some of that because now it's really crowded. Okay, so 66, and you're going to make a note right next to it, Alt-Int. So that if you're looking back at this and you're trying to figure out where the world did 66 come from, it came from the alternate interior angles concept. I accidentally needed to erase all of this. There we go. So we said this was 43, and we said this was 23 degrees. All right. Now find angle ADC. Trace your eyes over angle ADC. 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 So this, right? So that whole angle. Okay, multiple ways to go here. It's easier to feed off of your answer from the previous question. What was the measure of this angle over here? 66, right? This was, and I'm going to write it out here because if I write it over it, you're not going to be able to see it. But that whole angle was 66.
Mm-hmm.
Now I'm finding the one directly next to it.
Yeah.
Oh, 32.
The Adamite.
Who said that?
I
Yes.
did.
Consecutive angles are supplementary. If you just found, let's call it angle A, ignore the diagonal. Let's say angle A, corner A. How's that? Corner A. If you found corner A to be 66 and now we're finding corner D and they're side by side, it's the same concept as what we did over here.
Ah.
So 180 minus 66 is going to leave me with corner D, which is what? 114. So I'm going to make note 114, and I'm going to write next to it equals 180 minus the 66, so you'll know where it came from. In case you're looking back at this thinking, how did we get 114? All right, the next angle, ABD. A to B to D. So it's actually just this piece here. Lots of ways to go here. We just found this, when you're doing these problems, if it's possible, it's helpful to label your picture as you go because you never know what's going to help you with the next question. You just found this entire corner angle to measure 114, right? Okay, and now it's asking for just this little chunk right here, which is opposite. So then what does this whole corner have to measure? 114 as well. Right?
Yeah.
And what little piece of it do we already know?
degrees.
Yes, it is. We know this piece is 33, so we can subtract off 33 from 114 and you get 81. Make a note that that was 114 minus 33. Now you can see why for today we are just sticking to plain numbers. We're not doing algebra yet because it's already stressful enough with just plain numbers because there's a lot going on here. I'm passing to you page 35. Goes in your notebook. You are not doing this whole thing. As soon as everybody gets it, I'll tell you where to stop. Now you're welcome to take off with it. We've covered it. But as far as what I'm looking for when you walk in tomorrow, I'm looking for 1 through 6.
Thank you. Well,
I'm looking for 1 through 6.
that's all we gotta do.
The top of the paper, let me pull it up on my screen so it's in the video. I'm actually going to help you with a few, so don't pack up. Alright, so this is page 35. The top of the paper has this right here, and then it has these blank lines. You don't have to fill this in. This is just if you want to copy the properties over from your flip book. But you don't have to, okay? Coming down here to the practice examples. Your homework assignment for tonight and to be done in Flex tomorrow, so when you walk in at the beginning of class tomorrow, we can check it, is 1 through 6. There is no Delta Math. There is a paper assignment. 1 through what? 6. Thank you. Look at them. The ones with diagonals, if I was to guess, are going to be the ones that give you the most trouble. Let's look at number 1 real quick. Remember, 2 letters means it's a side or a diagonal. 3 letters with the little angle symbol means it's an angle measure. It says find the measure of AD. Now this is just numbers, no algebra. So AD, what would it be? Anybody else care?
8.
Yeah, it's 8 because it's parallelogram. Oh my, hold on. It would be 8. All right, what about DC? 15. There's really no excuse to get those wrong. It says find the measure of angle A. Your clue is angle D measures 68. D is next to angle A. So are they equal or add to 180? They add 180. So 180 minus 68 is 112. It helps to label your picture. All right, I'm going to jump to number 3. Finish that. Jump to 3. We got diagonals drawn. We have no angles here. So this one should actually not be that bad. It's when the angles is when it's tricky. We have no angles listed. It's just lengths. It says RT is 30. That means from here to here is 30. Which means, there you go, each piece of it is 15. All right, now let's start labeling. It says side UT. Well, UT is,
27.
there you go, it's a parallelogram, opposite sides are congruent. Then it says ST.
18.
18. Then it says VS.
7.
There you go. Then it says VT.
15.
All right, let's go to one of them that are angles, because those are the hard ones. I'm helping you with homework. Go to number 4.
Oh, yeah, homework.
This
This
is
is a homework.
homework.
You are out of yourself.
Number 4, we are talking about angles. You got to be careful here. The diagonals are drawn, which means look for what?
alternate interior angle.
Look for alternate interior angles. They are here. It might actually be easier to go ahead and find them and label what you can. If this is 21 right here, then this would be what? 21 as well. If this is 71 here, I'm drawing two lines, two arcs, then this would be what? 71 as well. Then it says right here, angle FED. F to E to D. Now, it's really hard to label that because of the diagonal drawing. Here's what I always do. I draw an extended arc so that it's going outside of the shape to tell me, hey, I'm talking about the whole thing. I draw an extended arc, like I'll even change colors. I'll get a colored pen sometimes. I'll draw a really big, exaggerated arc like that to tell me, hey, I am talking about that entire corner is 134. So that's one way you can label your picture. All right, so now let's find stuff. DEC. So you got to be careful. DEC means what's this? Well, if the whole corner's 134 and this chunk is 71, I just do what with those numbers? Subtract it, and what do you get?
53.
63?
Yeah.
So this is 63. Here's where it gets really crowded. Now we're doing CDE. CDE. So that means the whole corner.
Yeah.
Well, if this corner is 134,
Your bus changes
side by side,
bus 114 will double up on bus 16.
180.
Bus 140 will be bus 55. Bus 87 will be bus 121. Bus 107 is bus 130. And bus 117 will double up on 134. Again, your bus changes for today. Bus 114 will double up on 15.